Hello, Maria. Thank you for your question. This problem is an intermediate value theorem, and the idea here is you plug the values in, x equals -2, x equals -1 into this equation, and you get a y value back. And if the two values that you get back here at -2 and -1, one's positive, one's negative, one's positive, so long as they have different signs, the graph of the function must have crossed the x-axis because it went from positive to negative. And that's the idea. If it crosses the x-axis, it has to have a 0, right? A 0 here means a spot where the y value is 0. That's a root. And so it's just a question of plugging it in. So you can plug this in using synthetic division, or you can actually just plug it in, right? 5 times what? -2? -2 to the 5th minus 10 times -2 to the 3rd. Let's see. Plus 5 times -2 squared minus 8. Right? So there's one of the values. It seems to have done some weird rounding things. It's 104 to 57, right? Unless I'm reading this wrong, right? 5 times -2 to the 5th minus 10 times -2 to the -10 times. There we go. 5 times, and just having problems with my keys here. There we are. That looks right. -68. That's the value at -2. You're going to plug the same numbers and do the same thing now at -1. Just change those values. And then you found that the value at -1 is 2. And so you see that the value at -2 is -68. The value at -1 is +2. And because the value of the y value went from negative to positive, it had to pass through y is equal to 0, which meant that you ran through the x-axis, which meant that you had a root. In either case, there's a root between them, and it's given us by the intermediate value theorem. Let me know if you have other questions, and I'll talk to you soon. Take care.